Welcome back to Inquisitive Kids. In this video, we will be looking at the lesson Systems of Equations and Money. Applying your knowledge of systems of equations to money-related word problems. We've encountered quite a few different types of word problems using systems of equations before. And now that you have some sort of sense of what word problems involving systems of equations are like, so you've gained a little bit of experience, and you also know how to solve and set equations, this lesson is sort of just going to be more practice, but in a different type of word problem. So, this is part 2 of systems of equations in real life. Part 1 was last time, and feel free to go down into the description box because I have put the link to that video in the description down below. And I highly recommend you, if you haven't watched it yet, go watch it because it really is like the introduction of going from systems of equations to systems of equations word problems. So if you haven't watched that yet, pause the video right now to go down and watch that and then come back. The 2 learning goals for today is to being able to analyze the quantitative relationships included in the problem and using that to set the systems of equations and to solve it. And then we're also just aiming to become more comfortable with the steps of solving a system of equations word problem. Here's our introduction. The new year is approaching, and Common's father wants to give him a school bag and a personal stereo as a New Year's gift. So, as of when I'm recording this in 2022, a personal stereo is sort of like something that you can listen to music out of. It is sort of outdated, so we don't really use that anymore, but this is a bit old, so it's going to say personal stereo. So his father wants to give him a New Year's gift. Dad said to Condon, the sum of the unit price of the personal stereo and the school bag is $452, and the unit price of the personal stereo is $8 less than 4 times that of the school bag. How much is each of the unit prices of the personal stereo and the school bag? So, Condon needs to answer his father's problem. Can you help him? Here we're going to dive into applying systems of equations to increase revenue and to reduce expenditure. So in money economics, this is not an economics course, but we're going to go over some keywords and vocabulary that's going to be used. So revenue. Revenue is the income. So the amount of money that comes in into your business, into whatever, just the money that you earn. And to reduce expenditure, expenses, sort of the same thing, so we have to pay, right? Because if you're running a business or something, you have to first pay. Maybe you have to pay for the store you're selling your stuff at. Maybe you have to pay for the goods. Maybe you have to pay for the transportation. So those are all examples of expenses that you might encounter. So fill in the following blanks. If the purchase price of a commodity is $150 and the selling price is $165, what is the profit? The profit is revenue subtract expenditure. So the profit is how much more money you get, right? Because if you first spend $150, that's already minus $150, and then sure, your revenue is $165, but did you gain more $165? No, you haven't, because part of that was just filling up for the expenditure. So a lot of the times companies, really most of all of the times, you want to have a higher revenue and a lower expenditure. So what you're doing is the profit, remember, it's the expenditure subtracted from the total income. So subtract 150 from 165, you get $15. All right, now let's look at number 2. If the purchase price of a commodity is $150 and its selling price is $165, then the profit margin of the commodity is what? So this would be 10%. And what does this mean? Well, the profit margin is basically you take the profit and then you compare that profit to the purchase price or the expenses, so to the purchase price of the commodity. So here we know that the profit obtained is already $15. And we know that the purchase price is $150. So 15 out of 150, 15 is 10% of 150. So the profit margin would be 10%. Number 3. If a commodity is priced at $150, then the price after a 20% discount is. So if you have ever gone shopping maybe with an adult or with friends, discounts are basically when they have the sales price. But then they sometimes stores for business or strategy, they might give you a discount. So maybe like it's $100. You're trying to buy, say, a T-shirt, a very expensive T-shirt, and it costs $100. But basically, you negotiate, and then with the shop owner, and the shop owner decides to give you a 20% discount. So all you're doing is taking away 20% of the original price. So really what it's saying is 80% of the normal price. So you're subtracting 20% or you're counting 80%. So you're just going to multiply 80% to 150 at this case. Find what's 80% of 150, and then you get $120. And by now you probably is really comfortable with calculating with percentages and fractions. I'm sure you know how to do that already. But for some reason, if you don't, here is what I'm talking about. So you have $150, and you want to multiply that to, let's say, 1 minus 20%, which is really equal to 150 times 80%. And then you have 150, I like to use fractions, times 4/5, cancel out, and then you have 120. So this is the solution. Wow, we got $120. Question 4. If the price of a commodity is $200, then the selling price after a blank discount is $170. So now you don't know, right now in this question, you don't know the discount, but you do know the difference between 200 and 170, and that's $30. So out of $200, you have $30. So that would be a 15% discount. And now you got this is, the difference, right? You subtracted $30. So you have to pay $30 less. And $30 is 15% of $200. So that's why you have 15%. Question number 5. If the total income of a factory last year was X million dollars, and the total income this year increased by 20% compared with last year, then the total income this year is what dollars? Now, answer with a whole expression using X. The answer would be 1 plus 20% of X. A common mistake right here is just because you see 20%, you just write 20% of X. But it says increased by. So when it says increased by, it doesn't say of X million dollars. It said increased by 20%. So you already have what you have, and then you add the excess, the extra. So it's 1 plus 20%, not just 20%. If the total expenses of the factory last year was $Y million, and the total expenditure this year was reduced by 10% compared with last year, so reduced, then the total expenditure this year is blank dollars. Well, you would subtract 10% from 1. So since this time this is reduced by, you would be subtracting that 10%. Here we have addition because you're increasing it. Number 7. If the factory's profit this year was $7.8 million, then the equation that can be obtained from questions 5 and 6 is what? Well, we already know that profit, let me write this in orange, profit is equal to income minus expenses or expenditure. So, since we already know the how to express each of the income and expenses in whole expressions, subtract the expenses from the income and then you have the profit. So this is how you can show the profit. So, question number 1. What are the formulas for finding growth rates or loss rates? Right, so loss rates would really just be a negative growth rate. The original amount times 1 plus that growth rate would be the new value. Original amount times 1 minus the loss rate is equal to the new value. Remember to not forget this one right here, because you still have what you have at the beginning, and you're adding or subtracting from that whole. But really, you don't need two different formulas for this. If you think growth and loss is the opposite of growth. So loss would technically be a negative growth rate. So all you have to do is just look at this first formula right here. Or you could even just look at the second formula right here and think of growth as a negative loss rate. So really you don't need two formulas for this. Question number 2. Formula for banks. So this is all stuff that might have to do with banks, such as interest, principal, interest rate. So what is interest? It's basically when you have that money that you borrowed for someone. So say a person borrows from say $500 from the bank. So not only they have to pay back those $500, but they also have to pay interest. And interest is what you have to pay, say every month or every year. You have to pay the bank because you borrowed it in the first place. This is also a way why that allows banks to make money because they get interest. Okay, so this really, it shouldn't be up here. Principal and interest, of course, it's principal plus interest. Okay, profit, gross income minus gross expenditure. And now when we say gross, we're not saying it's disgusting. We're saying the entire thing. So it's really total income minus total expenditure. And we cover this, right? So profit is equal to income minus expenditure. Income, another word for it, is output value. In the profit rate, we also discussed, it's the income minus expenses divided by income times 100%. So according to the formula system listed above, we can list the systems of equations to solve basic money-related problems. Here's our first example. The profit, and here it's reminding you that it's total income minus total expenditure of a factory last year, was $2 million. This year, the total income has increased by 20% compared with last year, and the total expenditure has decreased by 10% compared with last year. So start thinking of what this could look like in mathematical terms. This year's profit is $7.8 million. What were the total income and the total expenditure of last year? Here's our analysis. Suppose the income of last year is X times $10,000, and the total expenditure last year was Y times $10,000. Then the values given can be organized as, here's what we know. Last year's income value is X, last year's total expenditure is Y. So these are the two variables that we set. We also know that the profit last year was, and this is all in 10,000, so it's not really $200, it's 200 times 10,000, which is $2 million. So here this would be 200. This year's, since the income increased by 20%, remember to have that 1 right there, so we can express this as X times the sum of 1 and 20%. And the expenditure this year is reduced by 10%, compared with last year, so we subtract 10% times y. And we know that this year's profit, given in the problem, is $780,000. So here is $780. This is what we know. So therefore, this year's total income value is equal to last year's total income value times 1 plus 20%. This year's total expenditure is equal to last year's total expenditure times 1 minus 10%. So the key here is to find the equivalent relationships. So anything that's the same, equal, is, these are all keywords that you should be looking for. Excuse my voice. I'm sick right now, so it's a bit hard to talk. Here's a solution. Suppose the income value of last year was X $10,000, and the total expenditure was Y $10,000 last year. Therefore, the system of equations obtained would be, and we'll just try to express everything using X and Y. Solved, X is equal to 2,000, Y is equal to 1,800. And since you probably already know and you're pretty skillful with the solutions to solving systems of equations, I'm not going to dive. I'm not going to continue talking about that. That's something that you should have mastered. Therefore, the total income last year was $20 million, and the total expenditure was $18 million. Example 2. The hospital uses 2 raw materials A and B to prepare nutritional products for patients after surgery. Each gram of raw material A contains 0.5 units of protein and 1 unit of iron, and each gram of raw material B contains 0.7 units of protein and 0.4 units of iron. If the patient needs each meal, including 35 units of protein and 40 units of iron, how many grams of each raw materials A and B in each meal meets just the needs of the patient? Well, let's first think about the equivalent relationships. Assuming each meal includes X grams and Y grams of each meal A and B raw materials respectively, we can list the following table. And also, just to pause here, notice how I'm first, since you're new to this, I'm first just writing out my thinking in tables so I could clearly just set my equations, and this has less room for mistakes. So we know that each meal includes X grams of meal A and of A material and Y grams of Y material. So here we can make the list. Total nutritional units needed per meal would be 35 and 40. So according to the question, we can get the system of equations. 0.5x plus 0.7y is equal to 35, and x plus 0.4y is equal to 40. Simplified, we have y is equal to 30. Substitute that into equation number 1, we get x is equal to 28. So our final answer would be, each meal requires 28 grams of raw material A and 30 grams of raw material B. Conclusion. So we first start with the word problem. We set variables, find equivalent relationships, set equations, and I think this is ultimately the hardest part, finding out which values you need to set as variables and finding the relationships. The rest, after you've gotten over that hump, that hill, the rest is a breeze. So you have the equations, solve them, you have the solutions, you double check, and then you just answer the problem. And this is a cycle. So this is the steps for solving word problems, not just money word problems, just all sort of problems related that uses systems of equations. Practice. A batch of goods is to be transported to a certain place, and the owner intends to use 2 types of trucks, A and B of the transportation company. It is known that the 2 types of trucks rented in the past 2 times are as follows. And you have a table listed out for you already, so you don't have to make it yourself. The company is renting 3 type A trucks and 5 type B trucks just to transport this batch of goods at one time. If the freight is calculated at $30 per ton, can you calculate how much the shipper should pay for the freight? So using what you've learned and the experiences you've gained from the past two examples, pause the video yourself and use this table to create your equations and your variables, and then solve. Okay, so based off of the table, the equation you got should look something like this. So you have two types of trucks, and maybe you could use different variables, but we are using x and y here. So you can transport, so truck A can transport x tons at one time, and B can transport y tons of goods at one time. Now you create the following equations. 2x plus 3y is equal to 15.5, and 5x plus 6y is equal to 35. Solved, x is equal to 4, y is equal to 2.5. The total shipping fee would be, and then see, your final solution isn't the final answer. You still have to use these values, put it into an equation, and then you have $735. Class summary. We learned all about systems of equations in real life. Remember, this is part 2. And we learned about growth rate, profit issues, all of that sort of stuff. We also covered equivalent relationships using charts. So those two charts that we used in the two examples were very, very crucial in helping us create the equations, create the variables. So I highly recommend you to do that. Maybe you can stop doing them after you're pretty skilled, but it's just a good tool even if you're already proficient, because with harder problems and more complicated ones, you need a really good way to organize your thoughts. So yeah, thank you for watching lesson summary. The two skills we learned today is to analyze the quantitative relationships included in the problem, and based off of that to set the systems of equations and to solve. Right? And one method that helped us do this, one tool that we used was the chart. And also to become more comfortable with the steps of solving a system of equations word problem. Right? And with the practice that we did, in the end, the solution wasn't the final answer. Our final answer we had to use that was multi-step, and that's more complicated, but you'll get the hang of it because that's something we'll be training with later in this unit. So yeah, that type of problem is it's multi-step, where after you solve the system of equations, you still have to use that, and there's more calculation, maybe another system of equation you have to solve. Yeah, so thank you so much for watching through Inquisitive Kids. Stay tuned, hit the subscribe button, hit the notification bell, and stay tuned for our next video.